through the solutions to the 2021 VCE Vcaa Further Maths Exam 1. My name is Jesse. I'm a tutor in Melbourne, and you might have already seen the channel before. I make videos now, put them up on my main business page, Simplified Study. You can check out other stuff as well, but let's get straight into the solutions. We sat this yesterday, so you're probably using the weekend to try and work out what's going to happen on exam 2. I'll give my predictions at the end, but we'll go through the questions. I've only got the matrices. I've got the core, statistics, and financial, but I've also got the matrices and networks because that was mostly what my students did. But if you do have access to the other two modules, the measurement and geometry and the linear programming ones, let me know. I think my email is linked. Just let me know and email it through a copy of it if you've got it, or a link to where you can find a copy of it. And I can do worked solutions for that as well and upload that as well. All right, so let me just move this into view. I'll be using the TI Spire, so if you use the Casio class pad, keep in mind that things might be slightly different in the way that you would do it, but they work pretty much the same way. So we'll move through pretty quickly as well, because I'm sure you're just looking for the basic answers and then the basic explanation to understand them and get some closure on it. The percentage segmented bar chart shows the age, and I'll also say as well, it's the first time I've actually looked at it, so if I've got any errors, just let me know in the comments and I can change them. But yeah, let's have a look. So the percentage segmented bar chart shows the age under 55 years and over of visitors at a travel convention segmented by preferred travel destination. So the variables age under 55 and over, preferred travel destination are both categorical. Also, my students might have put their own answers on here. We'll see if they're right or wrong at the same time, but don't worry about those. I'll do everything in orange. So they're both categorical. So even though you got numerical, it's split into two groups, under and over, and the other one's obviously all in words, so that's categorical. Question 2, the data displayed in the percentage segmented bar chart supports the contention that there is an association. So pretty much with these, any of the really simple ones are probably going to be wrong because you're trying to prove an association. You can't talk about just one group or some summary statistic. So if we look, the only one that I can see here looks like D and E are possible. D says 65% of visitors under 55, preferred domestic. Let's have a look. Under 55, domestic is white. That is 65% and 35% for international, so that's true. While 45% of visitors 55 and over prefer domestic. We can see international goes to 55, so the leftovers is 45, so that would be correct as well. So that would be D. Then we have the results could also be summarized, it's cut off a little bit, in a two-way frequency table. Which of the following frequency tables could match the percentage segmented bar chart? So we've got here, summarizing a two-way frequency table. Domestic, yep, and we had a sample of, did we get the sample size? No. Which of the following frequency tables could match it? Looks like we're just going to do it as percentages then. Okay, so that one's a bit annoying. So basically you just have to work through, I'm going to trust my students' answer here, but we just have to match the percentages. So under 55 domestic was 65%, 55 and over domestic was 45. And so now I just want to check if they've got the proportions right. So 91 out of 140 gives me 0.65. We'll bring that onto the screen there. So that looks good. And then the other one was 90 out of 200. So 90 out of 200 gives me 45%. And I'll trust that the other ones there are the leftovers of 200 and 140, and they are. So A would be the correct one. And you could do that for all of them, but luckily they put it at the first one there. The box plots below show the distribution of the length of fish caught in two different ponds, pond A, pond B. So usually you're comparing these. Based on the box plots above, it can be said that 50% of the fish caught in pond A are the same length as the fish caught in pond B. That doesn't even make sense because they've said 50% of the fish, like it's a group compared to the same length, unless they're comparing the middle 50%, which would be the box. Clearly they're not the same position, they're not even the same length, so that one's out. 50% of the fish caught in pond B are longer than, so that is 50% would be above the median. So we're looking here in pond B, this 50% are longer than all the fish caught in pond A. So if we just draw a line, we can see everything in pond A is below that position, so that would be true. So I won't rule out the others, I'll just keep moving. So B is also correct there. The stem plot below shows the height in centimeters of 20 players in a junior football team. A player with a height of 179 centimeters is considered an outlier because 179 centimeters is greater than. So we basically need the upper fence, which we know is Q3 plus 1.5 times the IQR. So a bit of work on this one. We have to find the median and then the Q1 and the Q3. So the median would be the 10.5 number, 20 plus 1 over 2, 10.5. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.5. So this is the median. And then from there, that would be 151.5. We don't really care. There's 10 numbers below. So half of 10 is splitting at 5 and 5. So 1, 2, 3, 4, 5. Right there, halfway between 148 and 148 is 148 for Q1. And then 1, 2, 3, 4, 5. And then we can see here, halfway between 158 and 160 will be 159. There we go, there's our Q3. Sorry, that was a Q1 and then a Q3. So the IQR is 159 take away 148, which is going to be 11, like that. And so therefore we can dump that in. Now it's got 159 Q3 plus 1.5 times 11. And we can just come over here, use the CAS. It's early in the morning, so normally I do things in my head, but I think I'll just do this just so I don't make a mistake. Plus 1.5 times the IQR of 11, we get 175.5. So that would be E on that one. That would be our upper fence, and we can see that 179 is greater than that, so it would prove that it would be considered an outlier. Then we have the relationship between resting pulse rate in beats per minute and age group is best displayed using. So here it's about the data types. So the relationship between resting pulse rate in beats per minute, that is numerical, and age group in categorical, like that. So really you can just kind of think about whether or not each one would work. Histogram is for numerical against numerical. Scatter plot is numerical against numerical. Parallel box plots works for categorical. You can compare them, so that would look pretty good. So I'll circle that at the moment. A time series plot, it's not time series at all. That'd be a trick with the beats per minute. And a back-to-back stem plot, that's when you're comparing just 2 groups. Here we're comparing 3 groups, no, 4 groups. So parallel box plot would be the most appropriate. It'll be C. Then we have 800 participants auditioned for a stage musical. Each participant was required to complete a series of ability tests for which they received an overall score. The overall scores were approximately normally distributed, with a mean of 69.5, standard deviation of 6.5. Only the participants who scored at least 76 points in the audition were considered successful. Use the rule, how many of the participants were considered unsuccessful. So they tricked us here, right? So the first thing is we draw out one of those curves. The mean goes right in the middle, so that'd be 69.5. 1, 2, 3 standard deviations either side. It's a bit messy, but oh well. Standard deviation was 6.5. So if we add 6.5 to the right, then we will get 76. And I think that's what we really cared about. So we don't really care about everything else. So this would be 34%, 13.5, 2.35, and 0.15, and the same thing backwards. How many of the participants were unsuccessful? They needed to score at least 76. So successful goes this way, so therefore unsuccessful is everything else. So this adds up to 16%. This adds up to the remaining 84%. So therefore 84% of 800, which is 0.84 times 800. And so we'll do that. 0.84 times 800 is 672 people did not make the cut. So there we go. So it's D. So we have to be offered a leading role in the stage musical. A participant must achieve a standardized score of at least 1.8. Remember, this is a Z score, which relates to a particular X value. The 3 participants' names and their overall scores are given. So these are overall X values. Which of the following statements is true? Only Amy was offered a role. So it looks like we've got to convert everything to Z scores. So let's do that. So we'd go X, take away the mean, divide by the standard deviation, and we'll do the same on all of the others, right? So let's again bring back CAS. I'll just move this out of the way so I can see. So for Amy, 81.5, take away 69.5, and then divide that by 6.5, then 80.5 minus 69.5, I'll do it like that, divided by 6.5, that's that Z score, and then 82 minus 69.5, divided by 6.5. check those are all good. Yep. And so there we go. So there are our Z scores now. So we can see only Amy was offered a leading role. Amy had 1.84, so she's good. She's above. Brian will not get an offer. And then 1.92, Sherry will. So A is out because it's Amy and Sherry. Only Sherry, no. Only Brian was not. That is true. There we go. So that would be the correct one. Both Brian and Sherry, no. All three participants, no. So C is correct. The heights of females living in a small country town are normally distributed. 16% are more than 160. So again, 16% is more than one standard deviation. We've got 16% sits to the right of this position of Z equals 1. And then that represents 160 centimeters. 2.5% are less than. So the lowest 2.5%, which is Z equals -2, that would be 115. So what is the mean and the standard deviation? So if we count out the number of standard deviations here, we have 1, 2, 3 standard deviations between them. So if we do 160 minus 115 divided by 3, we get our standard deviation of X. And so that there would give us 45 divided by 3, so 15 for the standard deviation. So it's either A or C. And then the mean would be 1 standard deviation back from 160 or 2 standard deviations forward from 115. So if we minus 15 backwards, we then get 145. Yeah, 145. And so therefore, the answer would be C. Oscar walked for 9 consecutive days. The time in minutes that Oscar spent walking on each day is shown. A least squares line is fitted. The equation of the line that predicts that on day 10, Oscar spends walking will be the same as the time he spent walking on what day? So that one is a bit annoying. We would have to do a regression analysis for a pretty small data set. So you'd go to statistics on the Casio. Here we're going to do this. So we've got day. I'm just going to call that X and Y. And therefore, we've just got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bear with me here. And then this will be 46. I'll do it over here. 46, 40, 45, 34, yep, 36, 38, 39, 40, 33, I've missed one. 46, 40, 45, 34, 36, 38, 39, 40, what have I done? Oh, it's only 9 days, that's why. Cool, there we go. It's an easy fix. So I'll come over here, then we'll just go menu 414 on this, regression analysis on the other one. And here it is over here. Okay, and so our X list, we're just going to put in X. Our Y list, we're going to put Y. Spits everything out. There's our equation. So we get 44 take away 1. Oh, they made it very nice. 44 take away 1X. So it's 44 take away 1X. And so now if we put in the 10th day, 44 take away 1 times 10 is 34. And that matches with day 4. That's what they're asking. There we go. 11, the table shows the weight in kilograms and the heights in centimeters of 10 adults. A least squares line is fitted. The least squares line enables an adult's weight to be predicted from their height. So whenever they do that, from whatever follows the word from is X, so Y from X. The number of times that the predicted value of an adult's weight is greater than the actual value of their weight is. So that one, I would go for a scatter plot and look at how many dots are below the regression line, because it says predicted is greater than actual. So the line should be above the dot on the scatter plot. So unfortunately, we have to do yet another one. And I might actually go with a brand new document altogether. Yeah, I might just go with a whole new one. Oh, should be able to get away with it. Let's see what happens. So I'll go list and spreadsheets. Wonder if it's going to auto-populate X on me. It is not. Nice. Okay. Y. Okay, so they said X was the height. You can see weight is Y. So, yep. So they've jumbled it around. So 173, 180, 184, 195, 173, 180, 192, 169, 164, 180. And then back up here, 59, 67, 69, 84, 64, 74, 76, 56, 58, and 66. Okay, so then we're going to go Control I, put in data and statistics. We'll get our scatter plot going. We'll put in X, we'll put in Y. There we go. And then we'll do our regression line. So that will come under Menu, Analyze, Regression, Show Regression. We'll do it in that form. And then how many dots are below the axis, right, or below the regression line, right? That would mean predicted is greater than the actual. So 1, 2, 3, 4, 5, 6 dots. So that would be D on that one there. Moving along, number 12, the time series plot shows the quarterly sales in thousands of dollars of a small business for the years 2010 to 2020. The time series plot is best described as halving. So seasonality is where you've got peaks and troughs at the same positions in every single year. So if we look at 1 year here from 2010 to 2011, we can see that the peak occurs in the second, or really like the first quarter, we'll say, quarter 1, quarter 2, quarter 3, quarter 4, and the trough occurs in quarter 3. If we look at the second year, the peak occurs in quarter 3 and the trough occurs in quarter 4. So that's already out, so it can't be seasonality. So anything with seasonality is now out. And then the next one, irregular fluctuations, is a possibility. Always leave that till the end. That one, seasonality as well, can't be it. A decreasing trend with irregular fluctuations. That would be the most correct because it's got a downward trend line to it. You could fit a trend line as well, but visually by eye, we can see it going down. So B has only got just irregular fluctuations. It's decreasing trend as well. Then a time series plot shows the points scored by a basketball team over 40 games. The 9 median smoothed points. I saw something on Reddit about this. They did a 9 median one, which is a bit strange, but they're just trying to mess with people. 9 median for game number 10. So we go to game number 10. We want to take this point. Then we want to take 4 points either side of it to fill in 9. So 1, 2, 3, 4. This is our cutoff here. 1, 2, 3, 4. There's our cutoff there. That's good. They've done that. And then we just scan upwards for the 5th number, because the 5th number would be the median of 9. So the lowest is here, 1, 2, then it looks like these are 3, 4, and then 5. So it happened to be that game number 10 actually was also the median value out of those 9, and that lines up with 110. So it would be 110 for the 9 mean smoothing. Bit of a trick question from them. And then a garden center sells garden soil. The table below shows the quantity of garden soil sold in cubic meters over a 1-week period. The quantity of garden soil sold on Wednesday, Thursday, Friday is not shown. The 5 mean smoothed quantity for Thursday is 206, and the 3 mean smooth quantity on Thursday will be what? Wow, it's an interesting one. So 5 mean for Thursday would mean that we would go 2 either side to here and here. So we'll call this X, Y, Z, or actually, what about we just do W, T, and F? I wonder if that was from Vcaa maybe. It's a bit of a joke. Let's see. So I'll do a bit of algebra here. So it basically means we were doing mean. So 186 plus W plus T plus F plus 346 over 5 would have given us the 206 centered onto Thursday. So we've got a bit of an equation. The 3 mean smoothed for Thursday would be W, T, and F. So W plus T plus F divided by 3 should give us our answer. So what we can do here is we can just solve for W plus T plus F. So I can multiply the 5 across, and really you could just call W, T, and F just X on the calculator, which let's actually do that. Let's just call this X on the calculator and solve for X. That way then we just dump it in here. So we don't actually have to know what each of the 3 numbers are. It's a bit of a trick. So instead, if I just go back to the calculator, set up a solve, menu 3.1, advanced calc on TI Nspire. So then we're just going to go with 86 plus X plus 346. Was that the number? Seems quite high. Yeah, it was. Okay. Oh, 186. That's why. 186. Yep. Plus that, blah, blah. Divided by 5. Oh, what's it done? Divided by 5 is equal to 206. And then solve for X. And that says 498. So now I can just do 498 for W plus T plus F. Divided by 3. and it gives me 166. I realize I wrote F twice here, that should be T. 166, so that's a very tricky question from them there. Then 15, a table below shows the number of visitors to an art gallery during the summer, winter, autumn, and spring. The quarterly average is also shown for these years. What is the seasonal index for summer? An annoying one. So I did create a spreadsheet for my students that couldn't end up transferring to their calculators that could automatically calculate seasonal indices. So a bit of a shame that it didn't work, and they did put it in there. They've given us the quarterly averages already. So that's already totaling up each of the years and dividing by 4. So now what we have to do is we just want the summer values. So we're just going to not bother doing all of it. We're just going to divide each by their average, 27,194, divide this by 23,183.5, and you'll get proportions, and then you'll average the proportions like that. So again, if we bring back the CAS, let's just do this all on the CAS. Bit annoying, bit tedious on the number typing. 29,685 divided by 27,194. That's that proportion. The next one, 25,420 divided by 23,183.5. That one there. And then 31,496 divided by 29,243. So each of those, and then we're just going to add each of those and divide by 3. So I'll just do plus. I'll just copy them completely unrounded, I guess, just to be totally safe. Plus this one here. Get the answer of those, divide that by 3. We get 1.08. 1.088. There we go. And then the number of visitors to a regional animal park is seasonal. Data is collected and deseasonalized before a least squares line is fitted. The equation of the least squares line is blah, 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 where month 1 is January. The seasonal indices for the 12 months of 2020 are shown. The actual number of predicted for February was closest to. So we're using 1.25. Deseasonalized we get first. So 2,349 minus 198.5 times 2 for February. And we'll definitely do that on the CAS. So 2349, take away 198.5 times 2, that's the predicted. And then normally when you get the deseasonalized, you divide by the seasonal index. So here we're going to multiply it back up, because if actual divided by the seasonal index is equal to the deseasonalized, then that means we can just multiply the seasonal index over to go back to the original, because that's what we actually want. And we do that, we multiply that by 1.25, we get 2,440. So then the next one, the following recurrence relation can generate a number of sequence of numbers. So a non-financial one, it's interesting. The value of L2 is 25, the value of C is what? So technically, L0, L1, L2, that is 2 jumps, that is plus C, so that is plus 2C. So if 37 plus 2C is equal to 25, then we can just solve that on the CAS, or you could go the difference between them as well. Let's just go for solve. So you just go solve, and then 37 plus 2C is equal to 25. Solve for C, C is -6. The next one, 18 and 19, amortization table. Deeper invests 500K in an annuity that provides an annual payment of that much money. Interest is calculated annually. Oh, they went annual. The first 5 lines of the amortization table are shown. The principal reduction associated with payment number 3 is. So really, it's just like a loan here. The principal reduction, you just subtract from the previous balance, you subtract the principal reduction, it'll bring you down to the new amount. So therefore, if 449,060.08 minus X brings us to 422,051.93, then we know that we can just solve for X there. So there's a lot of solving I've noticed, a lot of equations from them this year. So we can go solve 449,060.08, take away X is equal to 422,051.93. Oh, forgot my solve. X, there we go, $27,008.15. So there we go. The number of years in total for which DEEP will receive the regular payment of that is closest to. Now technically, it did say how many years will they receive the regular payment. So the last payment may not be a full amount. So what we're going to do is we'll bring up the financial solver on this one. And I might actually just bring this back up a little bit. There we go. And we'll go with menu 8.1. All right, so we're solving for the number of payments that she can receive. We also have to work out the interest rate. Wow, okay. So the interest rate, we can actually do a calculation. It's the interest on the first payment as a proportion of the balance previously, right? So it's 20,000 divided by 500,000. Just press tab. So that's what it is per compounding period. If it was monthly, you'd times it by 12 as well to get it to the annual. But in this case, that actually is the annual. We just want to times that by 100 to convert it to 4. So she's getting 4% interest. She's invested, so negative 500,000. She's receiving a payment of 44,000, so positive 44,970.55. We're working out when it hits 0. The payments per year and compoundings per year is 1 because it's annual. And we're going to actually solve for the number of payments, and it's 15. So realistically, no, they're not stuffing around with final payment stuff. It's clearly right bang on 15. So that will be D. It'll last exactly 15. Sorry, B. It'll last exactly 15 years. Sammy purchased a boat for 72,000. The value of the boat is depreciated each year by 10% using reducing balance. In the third year, the boat will depreciate in value by 10% of what? So that is 10% of V2, basically. So we know that it starts off at 72,000. It then times us by 90% or 0.9 to get to the next year. So this was V0. So at the end of 1 year, it's going to be that. At the end of 2 years, it's going to be V2. So times that by 0.9. And then in the third year, the boat will depreciate in value by 10% of V2. So we really need to work this out. So it's 72,000 times 0.9 times 0.9 or 0.9 squared. So we'll do that over here. Let me get rid of that. So 72,000 times 0.9 to the power 2. 0.9 times 0.9, 58,320 bucks. There we go. Enrico invests 3,000 in an account that pays interest compounding monthly. After 4 years, the balance of the account is the 3,728, blah, blah. The effective annual rate of interest. So with this one, this is after 4 years. So what we have to do first of all is we can use the financial solver to work out the nominal rate, and then we can use the EFF function. So we'll go to the financial solver. After 4 years, compounding monthly, so 4 times 12, 48. The interest rate, we don't know. We're going to solve that. That's the nominal. Invests 3,000, so negative 3,000. Receives payments at all? Doesn't look like it. Nope. So we're going to put 0. Future value is $3,728.92, and the payments per year are 12. So then we can solve for that. So it's 5.45% nominal. That's why A is there as an option. But then we have to dump that into the R effective. So I'll just copy that. We'll come down here, EFF, we put in the nominal rate, we put in the compoundings per year, and it adjusts, and it's 5.59. There we go. So then Joanna deposited 12,000 in an investment account earning interest at the rate of 2.8% compounded monthly. She would like this account to reach a balance of 25K after 5 years. To achieve this balance, she will make an extra payment into the account each month immediately after the interest is calculated. The minimum value of this payment is closest to, so we're just solving a PMT by the looks of things. So another finance solver, they're pretty heavy on that this year. Number of payments, she wants to do this in 5 years, compounding monthly, and she'll make a monthly payment as well. Do look out if they change the payments per year and compoundings per year. They've never done it, but they could. Be a little bit unfair though. So 12 months, 5 years, so 5 times 12. She's getting, I hate that you have to do that. She's getting 2.8% per annum. She's invested 12,000. She's got to put in a payment, which we don't know. She wants the future value to be positive 25,000 in those 5 years. And then we just solve for the PMT. There we go. So that she needs to be putting in $174.11 every single month. Cool. And then Bimal has a reducing balance loan. The balance in dollars of the loan from month to month, BN, is modeled by the recurrence relation. Given that the loan will be fully repaid in 20 years, the value of R is closest to. Okay, so this is the PMT. This relates to the interest rate, which we can work out. And this is the PV. And it's fully repaid in 20 years. So N is 20 times 12. And the FV will be 0. So again, we can work out the, where are we here? Yep, we can work out all the bits and pieces. So N was 20 times 12. Interest rate we're going to solve because that's related to capital R. Now this is 450,000. This was a loan, so positive 450,000. Making repayments of 2,633 a month. So negative 2633. They want the future value to be 0, and we can solve what the nominal rate of interest is, which is 3.6. So therefore, nominal rate is 3.6%, which is why they've got some of these as tricks. But then if it's compounding monthly, capital R is 1 plus 3.6 on 1,200, because it's monthly. And if we do that, we then get 1.003, like that. So that would be capital R there. Then Bob borrowed $400,000 to buy an apartment. The interest rate for this loan was 3.14% per annum compounded monthly. A scheduled monthly repayment that Bob will repay fully in 20 years was determined. Bob decided, however, to make interest-only payments for the first 2 years, so we've got to split it. After these 2 years, the interest rate changed. Bob was still able to pay off the loan in the 20 years by repaying the scheduled amount each month. The interest rate per annum for the final 18 years of the loan was what? Okay. So we've got to split it into 2 parts. We've got the 2 years on the interest only, and then we've got the remaining 18 years. Split it up, just get rid of that. So for this one here, starting off, we've got borrows 400K. Just get that right out of the way. Actually, we only need this. So positive 400,000, interest rate of 3.14%, so 3.14. The N should not be 400,000. Let me try that again. 2 years, 2 times 12, I think it was. Yep, 3.14. Borrows 400,000, so positive 400K. Making payments so that the future value still owes, so negative 400,000. That would be an interest only. We can work out what his payment would have been to do that, and it would be 1,046.66 there. Something's not quite right. Why is that coming out positive? No, it's negative. There we go. So PMT is negative 1046.67. We'll use the unrounded one though. And then after that, it says after these 2 years, the interest rate is different. Bob was still able to pay off the loan in the 20 years full by repaying the scheduled amount each month. So the interest rate was what? So basically, if we've only got one scheduled amount, that was 1,046. He was able to pay off his loan with this every month. So we can keep that in the PMT, right? We can now set this to go down to 0, pay it off, and then work out what the interest rate, what the interest rate was. Actually no, we have to change the number of years, 18 times 12. And then from there now, you can see what that rate would be. And it comes out 5.8, the interest rate per annum for the final 18 years. Interest-only payments for the first 2 years. After these 2 years, the interest rate changed. Bob was still able to pay off the loan in the 20 years by repaying the scheduled amount each month. The interest rate per annum for the final 18 years. What? Did I muck something up? Let me try that again. I'll do the interest only. Live recordings, huh? 2 times 12, monthly, first 2 years, yep. 3.14. Got the number in there, $400,000 borrowed. Still owes 400K. Yep, same thing. To make interest-only payments after these 2 years, the rate changed. Bob was still able to pay off the loan in the 20 years by repaying the scheduled amount. You have to assume the payment's the scheduled amount. the interest rate per annum was closest to. So it's got to be just the highest one. Should have read that closer, 4.07 then. That's a bit of a tedious question, unless I've made an error. If someone can notice an error there, but I think the 5.59 or whatever that I got was right, and they're just mucking around with this. That's really far away. It's a strange one. Then if matrix M, we're onto matrices now, is this, then the transpose is. So pretty much you can just do it manually, right? Just go down the first column, that should be the first row, 3, 8, 13, and then 2, 9, 7 in the second row from the second column. And that one matches 3, 8, 13, D. Every Friday, the same number of workers from a large office building regularly purchase their lunch from one of two locations, the deli or the cafe. It's been found that of the workers who purchase from the deli, so it's just D on a Friday, 65% will return to D. So D to D, 65%. So I'm just going to immediately go DC, DC, because that's what they did. D to D is 0.65, so therefore D to C would be the remainder, 0.35. And then on those that are from the cafe, C will return to the cafe is 0.55, so C to C is 0.55. So therefore the remaining 0.45 C to D. So just tediously working through, and we can see, yep, there we go, D is correct. Then the next one, simultaneous. Haven't seen one of these in a while. The set of simultaneous equations above does not have a unique solution, so that means that the determinant AD minus BC is equal to 0. So you can see here A times D minus B times C, so AB minus 4 times 18 has to equal to 0. So therefore AB minus 4 times 18 would give me 72 is equal to 0. So AB is equal to 72. So now it's just A and B have to be factors of 72. And so 2 times 36 would work. And that's the only one. All the others don't multiply to give 72. So it's A. Raymond and Norma are names that contain the letters, but in a different order. The permutation matrix that changes Raymond into Norma. So with this one, what I would do is look at this. They've selected 1, 2, 3, 4, 5. They've selected them in the order of the 5th, then the 4th, then the 1st, then the 3rd, then the 2nd. So 5th, 4th, 1st, 3rd, 2nd. So if I look through, I'm looking for, as I go down, for them to be in the 5th, 4th, 1st, 3rd, and 2nd column. So 5th, not the 4th, that's 1st, so that one's out. This one over here, 5th, 4th, 1st, that's the 3rd, so that one's out. 5th, no. 5th, 4th, 1st, 2nd, 3rd, so very close. 5th, 4th, 1st, 3rd, 2nd, it's E. Then A is a 7 by 7 matrix, B is a 10 by 7, which of the following is defined. This one's a bit annoying, you just have to test it. So with A, AB minus 2B. So AB would be 7 by 7, B would be 10 by 7, so already not possible, so that one's not defined, that one's out. A times the inverse of BA. So first of all, BA would be 10 by 7 by a 7 by 7. Insides are the same, so the outsides give the answer. BA is going to be a 10 by 7. We then do an inversion, and that's not possible because you can only do inverses of square matrices. So B is out. And then AB squared. So that would be A times B times B. So A times B is 7 by 7 times 10 by 7. Already not defined. That one's out. A squared, 7 by 7 squared is 7 by 7 times 7 by 7. So insides are good, outsides are good. So that's AB, that's A squared. Then I want to do take away B times A. And I think I did B times A before. Yep, that gave a 10 by 7. That was from down here. And you can't subtract those because they don't have the same dimensions. So it should be E, but let's just check. B transpose. That's going to be just flipping around the row and column, so it'll be a 7 by 10. And if I do then A times B, so that'll be 7 by 7 multiplied by a 7 by 10, insides are the same. Gives me an answer of 7 by 10, so E is defined. Make you work for that one, Jesus. And then a fitness center offers 4 different exercise classes, A, B, C, D. A customer's choices of fitness classes expected to change from week to week. According to this transition, an equivalent transition diagram is constructed. The proportion for one of the transitions is labeled W. You can see that just here. The value of W is what? So we have to match. We've only got a couple of proportions here. So we've got 20%, but I can see that's in 2 spots here. And then I might switch colors. We've got 25%. 25% is here. So that one's more restrictive. So I know now from B to D. So therefore this is B and this is D. If that's the case, then that means that the other 2 are C and A. And I can see that A to C is 20%. C to A is also 20%. So it doesn't really matter which of these 2 are it. Because it should just be 20% in both directions, actually. A to C, C to A. Yep. So I might just copy with what my student's done there, just put C there, A there. And now we can know A to D, in this case, is going to be A to D 15%. Like that. I'll just check, though, if we did put A over here and C over here, then suddenly it would be C to D. And C to D is 0, which is not given. So they're using that to work out which direction to put the labels. So the first one was more correct, so it's B. Then we have the matrix Sn plus 1 is determined by blah blah blah, so a recursion. C is a column matrix. Matrix S2 is equal to what? Okay, so they've made us first work out what C is. So if we do that, we're going to have to go on the CAS here. And I'll get rid of this. And I might define a few matrices here. So I'm going to define S as S0. Create a matrix, 3 by 1. So 21, 51, 31, done. And then I'll define T as the transition matrix. That is a 3 by 3. There we go. So 0.6, 0.1, 0.3, 0.3, 0.8, 0.2, 0.1, 0.1, 0.5. There we go. And then I'm going to do T times S to see what it would have been without the adjustment. And it gives me that. And then it says that if you take away C, you get S1, which is 24 and blah, blah, blah. So 27 minus something is going to be 24. So that would be, oh, how can I do this? I might just move this over here. So 27, 53.3, and then 22.7, take away matrix C gives us S1, which was 24, 54.3, and 20.7. So I can do little individual calculations. 27 minus 3 would give me 24. 53.3, take away something goes up by 1, so that would be a -1. And then 22.7, and then take away something gives me 20.7, so it's taken away 2. So I'm just going to put 2 because you've already got the takeaway there. You could also set up a solve and solve matrix C if you prefer. But there we go. So now we've got matrix C. So we can come back. Now we just have to do S2. So all I can do now is I've already got this here. So I can just go S1 is going to be, I might just type it in. Matrix create 3 by 1. So S1 was 24, 54.3, and 20.7. And in fact, I realized I need to do T times S1 and then take away that C matrix that I just did because I didn't bother to define it. And that's a 3 by 1 as well. And we're just going to put 3, -1, and 2. And that should be the state matrix number 2. So 23.04, 55.78, and 16.18. So it's A. Cool. A new colony of endangered marsupials is established on a remote island for 1 week. The marsupials can feed from only one of the 3 feeding stations, A, B, or C. On Monday, 50% of the marsupials observed at A and 50% were observed at B, no marsupials at C. So that is actually a state matrix in percentages. So 50, 50, and 0. A, B, C. The marsupials are expected to change according to this. Let Sn be the state matrix showing the percentage of marsupials observed at each of them n days after the Monday. So this is Monday as well. That way then Tuesday would be S1. The state matrix, blah, 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 from Tuesday to Wednesday, the percentage of marsupials who are not expected to change their feeding patterns. Okay, so first we have to work out Tuesday. So again, I'm going to have to redefine T. Bit of an annoying question. 3 by 3. It'll override it now, so 0.4, and then where are we? 0.1, 0.2, 0.2, 0.5, 0.2, 0.4, 0.4, 0.6. I'll just check that that's worked. Yep, it's all good. So now we're just going to go T times the Monday. There we go. 3 by 1. So 50. 50, 0. That will be Tuesday. And then we want what percentage are not expected to change their feeding patterns. So, oh, that's a sneaky one. So what that means is now it's the proportions from T of the Tuesday ones. So 25, 35, 40. 25, 35, 40. So the ones that are not changing are these ones here down the leading diagonal. So it means that 40% of 25% are not going to change. 0.5% or half, 50% of 35% are not going to change. And 60% of 40% are not going to change. So we can do little calculations just there. So 25 times 0.4 plus 35 times 0.5 plus 40 times 0.6. It'll be 51.5% of them will not be changing, just like that. And then the networks and decision maths. I hate this topic. So consider the graph below. There's some easy ones in there though. So the number of vertices with a degree of 3, counting the number of lines coming out, so the number of edges. That one's got 3, that one's got 3, that one's got 3, that one's got 3, and that one's got 3. The others have 2 and 5, it looks like. So therefore, there are 5 different ones with a degree of 3. 5 friends ate fruit for morning tea. The bipartite graph below shows which types of fruit each friend ate. Which one of the following is not true? So only Lee ate pear. So you go to pear. Yep, only Lee is connecting to that. So that is true. We're looking for the false one. Eric and Kai each eat apple. So Eric eats apple. Yep, Kai eats apple. So that's also true. So that's out. Van only ate strawberry. So we look to Van. Nope, he also ate oranges as well. Quinn and Kai ate banana. So Quinn and then Kai, they both ate banana. That's true. Orange was the most eaten type of fruit. Hang on a second. Quinn and Kai. Yeah, what? Van. Oh, yeah, we're looking for the false one. Got tricked. Always get tricked by those. So Van only ate strawberry. No, he also ate other stuff. So it's C. And the other two are true. Consider the graph below. The number of faces is. So we've got, let's see, we've got 1, 2, 3, 4, and then the unbounded 5. Consider the directed network, the number of vertices that cannot be reached from X. So we're trying to start here. We're trying to get to other vertices. So we can get to this one. We can go around, we can get to here. I can go to here. I can't go out from there, but I could go back and go to here. And then I can go to here. I can go to here. It doesn't seem that I can reach this one at all. There's no way that I can get there. So there's only one that I can't reach. Then question 5, consider the graph. Following statements. The graph is planar. That would be true. Unfortunately, my students got that one wrong. That would actually be true. There's no crossovers anywhere. The graph contains a cycle. Yep, there's you can go like that. Or, well, I mean, you could just go like this, or you could go here on a loop, cycles like that. So that's also true. It says a cycle, but I'm going to assume that they mean one or more. The graph contains a bridge. So a bridge is a single line connecting two parts. So this is not a true bridge here because there's not another loop. It's technically connected as part of it. So not a true bridge. The graph contains an Eulerian trail. So Eulerian trails, we've got to be able to go through everything and follow. Yep, so we can get a trail like that, and then we can do v plus f minus e is equal to 2. You might have it in other ways. So vertices 1, 2, 3, 4, 5, 6. Faces 1, 2, 3 for the unbounded. Edges 1, 2, 3, 4, 5, 6, 7. And we'll see, so that gives us 9 minus 7 equals 2. So that is also true. And then the graph contains a Hamiltonian path. So Hamiltonian means that you go along every single, you visit every single vertice, but you don't necessarily use every single edge. So like this, like that. So that is possible as well. So there we go. And so therefore, that is also true. And then how many of these statements, oh wait, no, I got that wrong. You go along every edge without repeating edges, but you can repeat vertices. And it's not possible. You can see I'll try it a couple of other ways, but it doesn't look like it's possible. I'll try to end here maybe. Yeah, no matter what, I have to backtrack. So that's actually not true. And so therefore there's 1, 2, 3 that are true. So it is C. Then we have the directed graph below shows the sequence of activities required to complete a project. The time taken to complete each activity is given in hours is also shown. The minimum completion time for this project is 18 hours. The time taken to complete activity E is X. Where is E? There it is. Okay. The maximum value of X is. So with this one, if we know that it's 18, let's first try to work out where the possible critical path is. So we'll forward scan. So we've got 4, 7, then this would give us, if we just go along this way, would give us 11 plus 7 is 18. So this is critical. We've found it, has to be critical. It may be paired or tied with something else. Then we can see if we go along the ones that have X, we've got a point of convergence here. So we've got 5 to get to here versus this one takes 4 plus 3 is 7 plus 1 is 8. So the slowest path in there. And then if there's 7 here, we've got to meet the critical path on time without holding everything up. So the critical path comes in at 11. So the difference here is 3. So the longest that this could take is 3 without holding up and becoming the critical path in any way. So that would be 3 for that one. And then the network below shows the pathway between 5 buildings. An adjacency matrix for this network is formed. The number of zeros in this matrix is. So I will redo it, but I hope that my students gotten it right here. So JKLMN, JKLMN. Right. Looks like they've done it the other way, so ours might be inverted. We'll just see. It doesn't really matter though. Do we count the number of zeros? That's why they've not given you a structure. So let's see. J first. I'll just go down the column. How many ways to get to each of them? So J to J, you got to be really careful because these don't count as nodes or vertices. So is there a way for me to get looping from J back to J without passing through a node or through a vertex? No. J to K, I can go one way like this. I can go 2 ways. So that would be a 2. J, well, really I'm looking for zeros, right? So I should probably just bother with the zeros. J to L. So I've got 1 here. J to L. I can go, nope, I can get 1 there. That one works. So yeah, that's got at least 1, so that's out. And I'm also going to do just the leading diagonal because it's just a mirror image to the other side. So then I'll do a little grid so I don't get lost. So I should have 2 numbers here, 3 numbers here. Oh, it's a little bit wonky. That's M. And then N down the bottom. So then, yep, J to L, that had 1. J to M, there is no way that I can get directly to M, so that's a 0, so that counts. And J to N, I can definitely get there, so that's not it at all. Then K to K, nope, I can loop around just through here and not go to any other town, so, or any other building, so that one's not it. Then K to L, I can definitely go to K to L right through here, so that's not it. K to M, I can get there as well. K to N, doesn't look like I can get to N directly. No, cool, everywhere, yep. So that one is a 0. Where are we, K to N? And then L to L. Oh, that one doesn't look like I can loop. Nope. Then L to M. I can get there, so that one's not it. L to N. I can do that one as well, so that's not it. Then we've got M to M. That one's not possible to loop, so that one's a 0. And M to N also can't get there either. So there's 1, 2, 3, 4, 5, 6 of them that I've got 6 zeros. Oh, and then there'd be more on the other side. So the ones that are right along the diagonal. Oh, N to N. Hang on, I've got to do N to N as well. Did I do that one? M to M, M to N. No, and then N to N. I cannot loop either. And then, oh, I do have to do it. Okay, so in that case, let me just redraw it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we had 0, and then 0, 0, 0, 0 here and 0 here. So they all like reflect around this. So this one here would go to 1 over, so that would go to here. These ones are already on the line, so they don't reflect. And this one, which is in row 5, column 2, will now go to row 2, column 5, all the way over there, like that. So that is 1, 2, 3, 4, 5, 6, 7, 8 of them. And then finally, I think this is the last question. A network of roads connecting towns in an alpine region is shown. The distances between the neighboring towns is shown. The region receives a large snowfall, leaving all roads between the towns closed to traffic. To ensure each town is accessible by car from every other town, some roads will be cleared. The minimum total length of road in kilometers that needs to be cleared is. So this is just a minimum spanning tree. You just need to be able to connect all of them. And they've gone and put X and Y. Brilliant. I'm just going to test each of these and see what happens. So if X equals 50, they're playing around with just a few combos. So if I let X equal 50 and Y equal 55, then I'll do a minimum spanning tree. I might start straight from here, I think. Yeah, probably lots of options. So 22, then the shortest path out from any connected point looks to be 36. Then the shortest path from any connected point looks to be maybe 40. Yep. And then the shortest connecting path, no, actually 47, never mind. No, 40, yeah. 40, shortest connecting path now. We've got a 52 over here, a 50 and a 52, so a 50 wins. And then from there, the shortest now is definitely a 29. Shortest now is a 30. And then the shortest connected 55, 44 looks to be the winner. And then we've just got to connect these two now. So we've got a 55 or a 52. Looks like the 52 wins. And then a 55. And that would be our tree. We're then going to see if it adds up to 361. So 36, 22, 40, 50, 55, 52, 29, 30, and 44. My God. Okay. So 36 plus 22 plus 40 plus 50. Hope I'm not making a silly error here. 52 plus 29 plus 30 plus 44 gives us 358. Doesn't quite add, so I'm just going to leave that one off. If we switch Y to 60, I'll see if any others. Yeah, I'm going to try and keep my numbers relatively similar. Switch that to 50. Probably changes everything, so I'm going to have to go back, unfortunately, and redo the tree. So 22, 36, 40, and at this point then, 50 now looks to be the lowest, and 50 again, and then 29 looks to be pretty much the same. Well, it should be 30 first, and then 42. Oh, I just realized, I think I went 44 on the last one. I should have probably gone 42, so 44. Yeah, that should be 42, so that would have been 356. But anyway, 42. And then only got to connect that one. Looks to be the shortest is 52. There we go. So I think that is exactly the same as what we had before. So that should be 356 as well. So that is not going to be it. So then the next one, 55, 55. Okay. So if I change this now, 55 and 55. Then we've got, Okay, so start again. So 22, 36, 40. Shortest now is 52. That looks like it's changing things a little bit. Then the next shortest is going to be a 55 here, and then a 55 up here, and then a 30, a 29, and a 42. And now we've connected everything. So that one I'm definitely going to add up. So we've got, scanning along, 55, I'll go right to left, plus 36, plus 22, plus 40, plus 52, plus 55 along the top, plus 30, plus 29, plus 42. And I get 361 on that one there. So it didn't add to 366, that's interesting. All right, and then, so they're maybe not going for the minimum, like still a minimum tree, but it's definitely got lower options if X and Y were different values. So 55 and 60, now it's pushing up a lot more, which makes me think that these are gonna be where the answers are really gonna sit. So 55 stays the same, this pushes to 60. We'll redo, this is such an annoying question for the end of the exam, Jesus. So again, the shortest is gonna be 22 and 36. And 40, you got to be careful about following patterns too when you start getting comfortable with these. Then from there, the shortest path out would be, looks like a 52 this way. And then we can do a 52 that way. And then a 42, a 29, a 30. And then everything is connected. Please let that be the one, Jesus. So I'll go left to right, 52 plus 42 plus 29 plus 30. Down the bottom, we've got plus 40, plus 22, plus 36, plus 52. That gives us 303. Am I missing something? Oh, I've not connected the last one there as well. So the shortest way to get there is a 60, whether it's through Y or through that one. So plus 60, you get 363. Wow, they're pushing us right to the end, unless I've made an error. Okay, so 55 and 65 now. 55, 65. Okay, so 55, 65. All right, so 22, 40. Nope, all 36, and then 40. And then shortest path out is a 52. 52 this way, 49, 29, 30. And then the shortest path, still 60. Unless I added it wrong. Let me do it again. So 22 plus 40 plus 52 plus 42 plus 29 plus 30. Did I get the 36? No, so plus 36 plus 52 plus 60. Gives me 363 again. So I did do it right. Okay, I must have made an error on the first ones. Damn, I have to go back through. Let's go right back. I'm going to go backwards at 366. Seems good because that one seemed to be weird. Maybe it is B. I'll just go from A. So X is 50. Y is 55. Shortest path, 22, 36, 40. And then shortest path out is a 50. Then the shortest path out is a 29. And then the shortest path is a 42. Well, no, not a 42 yet. It's a 30. Then the shortest path is a 42. And then to connect this, we've got a 55, a 66, a 52. So 52 is definitely the best option, like that. Let me just re-add it. Maybe I just added something wrong. Left to right, 42. Oh. 42 plus 29 plus 30 plus 50 in the middle there, plus 40 at the bottom, plus 22 plus 36. I must have just missed a number. Plus 55 plus 52. 356. It's definitely not it. Oh, hold up. I haven't connected this one. And the shortest path to that is 55. So plus 55. Gives me 411. Something is surely wrong. All right, we'll try B. C was the one that went weird though. I'm going to try C actually. 55, 55. Seems more likely. 22, 36, 40. Then the shortest path out from here is 52. That definitely pushes in a different direction. And that, 52 and 55. Can't see any errors there. So then 50, I'll go from the right here, 52, 55 plus 36, plus 22, plus 40, plus 52, plus 42, plus 29, plus 30. I think that's everything. Everything's connected. 361. Oh God. All right, let's try B. It's got to be one of them now. I'm circling in on it, but geez, I don't envy you guys having to do this one. What the hell? It's got me tricked. 361, 50 and 60. Okay, so 50 and 60. Didn't misread something. Every other town, some roads will be cleared. Yeah, cool. That need to be cleared. Okay. Wondered if they said something like did not need to be cleared. Jesus. So 50 and 60. All right, so 22, 36, 40. Shortest path now is a 50. Shortest path is a 29, a 30, then a 42, and then a 52. That feels better. Yes, because I got a 60. I think I got 361. No, that's lower. How is that going to work? Oh, wait, and then still got to connect to this point, and the shortest path is a 60, whether we go here or here. Keeps pushing higher. Have they made an error? The distances, the region receives a large snowfall, leaving all roads closed. To ensure each town is accessible from every other town, some roads will be cleared. The minimum total length that needs to be cleared. Definitely that. Okay, so right to left, 60 plus 36 plus 52 plus 22 plus 50 plus 40 plus 42 plus 29 plus 30. And I'm getting 361 now with 50 and 60. Okay, so it's B. There we go. Geez, that took a little bit longer than expected. All right, feel free to skip that. Well, it's too late now. You've already sat through it. Hopefully you skipped ahead. I'll put a timestamp or something so you know. While I work it through, I won't have time to edit this. I'll probably do like a smoother version of it where I edit it all out and fix up some of the ums and ahs and things like that. But there we go. That's a full run through of the matrices, networks, financial, recursion, and statistics for the 2021 exam 1. So my predictions, looking at that, it was a bit of an interesting one. They definitely had some trickier questions, but they always do in exam 1. It didn't look like they had much to do with actually using transition matrices as they could. So exam 2 always has a lot of transition matrices. I'll stick with matrices for the moment. There was nothing on dominance matrices, which is almost always an exam 1 question type. So expect dominance matrices probably having to rank people tomorrow or on Monday. And then for networks, there was no real crashing activities. So there should be a crashing question at the very end, unfortunately for many, I think. And then there was no precedence table. So we can expect that there should be a precedence table and activity network with a little bit more forward and backward scanning, maybe to do with float times. And then outside of that, we didn't see, I mean, they've never really done a Dijkstra's algorithm, but there was no Hungarian algorithm. They did a bipartite graph, but avoided Hungarian altogether. So I would say that they'll have something, even if in part, something to do with the Hungarian. And then from financial was very, very heavy on the financial calculator, which normally they leave for exam 2, but they only had one question at the end that was to do with a change of rate, and it was a relatively basic one as well, where there was not really a lot of changes. So there should be the last question for financial on Monday should involve a change of circumstances or a lump sum payment. So check out the past exams. I think the 2016 exam 2 has a question about Ken and his caravan. Make sure you do that question, because that I think will be relevant for Monday. And then on statistics, we saw not a lot in terms of, there was nothing on residuals. There was no transformations, and let's see what else. Not really a lot with extrapolation and interpolation. They always have one of those on there, so look out for those. I think transformations will probably be one of the bigger ones that they'll do, because there was literally nothing on that, so that's a bit surprising. So they would be my predictions for it. So study hard this weekend. Hopefully you've gotten some closure on this exam. If it's gone well, congratulations. If it's not gone so well and you've marked it and realized you've made a few errors, don't worry, because that's why we've got 2 exams in this subject. And you'll have a chance to redeem things in exam 2. Ultimately, people generally perform worse on the exam than in the SACs, because you're being asked to be assessed on everything all at once under time pressure and with a lot more pressure on your shoulders. So try to relax, take an easy weekend, study lightly for exam 2 and refresh some of the content, and good luck on Monday.